Hi everyone, this is Karthik. So in the session we'll just speak about the updates from the litmus project. So it's been quite a while since we have discussed about litmus. So there have been some recent developments over the past few months that I would like to share with the community. So going ahead, this is what we have for the agenda in this particular session. We will discuss about what litmus was or what was the objective with which litmus was launched, and we'll just recap a little bit about the capabilities and features that were available in the litmus project during the time of KubeCon earlier this year, and the changes that have happened since then, and the learnings that we had that we got from the community and the users, and what all the implementations that have happened as a result of the same. Following that, we will just take a brief look at how litmus is being used in the OpenEBS CI infrastructure, how it is being used to power the E2E stage of the OpenEBS CI. And we'll also spend a few minutes talking about the roadmap items that we have identified and which has been received from the community, and then probably take questions after that. Okay, so just to recap about litmus, the prime objective of litmus is to ensure that there is a decisive way of saying that a stateful application can work with the storage provider. So there are multiple requirements that a stateful application has from the storage. We will also interchangeably call the stateful application as the workload also. So in terms of the resiliency of the workload, its performance, and certain storage specific functionality that it might have, such as backup and storage high availability, etc. So there's a need for us to tell whether a stateful application of a given type can work with a storage provider to obtain all these capabilities. So litmus was created as a way to test that. So it's primarily litmus is primarily a test enabler that will help identify all these capabilities. It should be open source and easily extendable. The way litmus was conceived was the users should be able to contribute to the test, and they should be able to both extend the infrastructure as well as extend the test suite itself. That was one of the goals. And the third goal was to have it pluggable at any stage of the any stage of a DevOps pipeline for the stateful application. This is not meant to replace the test stage of the application DevOps pipeline, but rather just add on and help with increased visibility into how the application performs with a given storage provider. These were the goals, and based on this, what we had earlier was a few tests that could be launched from a container. So the litmus concept was, in simpler terms or in Kubernetes terms, it was to be able to run a test from a job. So we created a set of sample tests. Example, running a MySQL storage benchmark test using the TPCC workload generator, performing min.io deploy with a desired number of storage replicas. So all these tests were basically jobs, Kubernetes jobs. So when you launched the Kubernetes job, the resulting pod would actually run the test. So it would actually launch the application along with a given storage provider and would perform the necessary test business logic and end. So this was more like a proof of concept that we had to show how tests could be run like this, run from a container. And the other capability that was presented during that time was to have a framework which can define new tests in a very simple way, almost English-like manner. So we used the Godot framework to pass a set of test statements into Go code. Basically, it was parsed and Go code was generated. This Go code was basically encapsulated in a container which was run as a job. So the aim or the objective behind this capability was to help the users participate in defining the E2E. The third capability that was there was an executor framework, which would help users to create infrastructure, test infrastructure or test bed, that is to launch the Kubernetes clusters, install the provider, and run the tests that we just discussed. So the concept of litmus, the project and its intent were well received. And along the way, there was some learnings that we got from the community, from the users who reviewed the project, came up with the following suggestions. I'll just go through them and also in subsequent slides talk about what were the changes we made based on these learnings. So one of the important or the first feedback that we got was we need a usable suite that is there, which customers can go ahead and use already. While it is necessary for us to engage the users in creating more E2E tests, probably even ahead of that, even before that, there was probably a ready set that was needed for the users to go ahead and start using for some popular applications, popular type of chaos, popular type of functionality test on some standard applications was what was needed. So that prompted us to actually create more chaos modules in litmus and other functional modules. So that is one of the learnings that we got. The second learning was there was a need to compartmentalize the tests. So litmus along the way has morphed into or has sort of grown into a chaos centric framework. That is, though there will be functionality tests, though there will be performance and benchmark related tools and litmus books or litmus jobs, the primary function of litmus would be to test the resiliency by performing more and more chaos. So the way litmus was, we were having a application that we would launch, perform the chaos, and then exit. But there was a call from the community for us to create chaos modules that would work on existing applications. So there was a need to compartmentalize the test and split it up into different subtests, each runnable in itself. So this was done. So there has been an effort where we have separated out application deployments into separate litmus jobs, the chaos tests themselves into separate litmus jobs. So this was one of the learnings. The next one was about having a more flexible way to set up the infrastructure and the providers. So we just spoke about the executor framework having the ability to or having the necessary code to create the clusters. So the infrastructure as code modules in Ansible and Terraform were available, but that necessitates availability of those packages and a lot of dependencies that has to be there, that has to be pre-installed before the user can actually use them. For example, it needs Ansible to be pre-installed, and it needs the paths to be defined, inventory files to be generated, etc. And that was actually discouraging to some of the community. So they were asking for a more flexible way to set up the infra and the providers. So we basically converted them also into the litmus model. That is, the infrastructure setup and the provider setup now also are litmus jobs. So you could use the same paradigm as the rest of the litmus tests. That is, you will have a Kubernetes job, in which you're going to define the desired characteristics or desired properties via environment variables, and they will be deployed in a cluster. So the infrastructure and provider setup is being done in the same way now, instead of having dependencies on the system. So as I'm talking about these, probably in the subsequent slides, we will also go through some code snippets. I will just take you through the respective um, uh, features in the repo itself, and we'll also just produce the design doc where all this has been explained in greater detail so that you could take a look at it afterwards. So that was about how the infrastructure and provider setup has been made simpler. One of the glaring missing items that were there in the litmus jobs was a lack of a way to exactly determine whether a test passed or failed. So that information was actually buried in the logs. A user would have to actually rummage through the logs to identify certain certain test pass or fail flags. So instead of that, now we have a better results mechanism where the tests are going to update a result custom resource, and the result custom resource can be queried for a test pass or fail. So that has been changed, and there is improved logging. We had logs capability earlier also. Stern-based logger was being used, but the logger did not have the ability to um, uh, collect all the logs into a single location. There were disparate places where the logs were being placed, the pod logs in one place, the uh, other logs, node logs in another place, etc. So that has been fixed. Also, we were taking a hard duration value for the logger, and the logs would be collected only for that duration in the test. Now it has been made more flexible, and the logger is going to be alive for as long as the test container is going to be alive. So there has been some enhancements made in the area of logging. So just to expand on the developments that I just spoke about, the compartmentalized tests now can be categorized as app deployers, liveness jobs. So the liveness jobs are going to basically take some app information as ENV, and then they're going to monitor the liveness of the applications themselves. So this is basically to buffer for a case where the application might themselves not be equipped with liveness probes and readiness probes. So we are going to have external liveness monitors for the applications. Then there are actually load generator jobs. So people who are interested, users who are interested in actually performing certain stress workloads on the applications can use this load gen litmus books, which will generate application specific load. I'll just probably take you through what are the tools we're using for these load gens later. And then the actual crux, the chaos jobs are present. So there are some functionality jobs also that are being added. So the tests, so the app deployer, liveness, loadgen, all are being considered as individual tests themselves and have their own loggers, and they have their own results that are getting recorded. So this is one of the changes that has been made. So earlier we had support for basically we were using only MinIO and Percona MySQL in our application suite. So now there are more applications that are being supported. The application deployers and tests are now present for Percona, MongoDB, Cassandra, PostgreSQL, and Jenkins. Some of them deployment, some of them are stateful sets. So the infrastructure, earlier there was support for building clusters on bare metal using KubeADM. Now there is support for building the clusters on GCP, AWS, Packet, and Azure. So GCP and AWS are created using COPS. Packet cluster is instantiated using KubeADM, and Azure is basically using EKS. So they're creating a cluster on EKS. So in subsequent sprints, support for more cluster platforms may be added, like GKE and EKS. There are now separate litmus books for installing the provider. So there are litmus books for both the operator as well as storage class deployments. And there are litmus books which are in progress for creating local PB as well. So whatever were Ansible playbooks earlier are now being converted into litmus books, litmus jobs. From the chaos perspective, um, um, we have added more chaos tools, kubectl-based chaos utils, Umba, and chaos cube-based chaos utils have been created. So there is a separate chaos library which has been created. So as a result of compartmentalization of the test, a separate library for chaos has been created where all the utils for the tool specific and provider specific chaos will be created. So we have chaos support for all these set tools. So the logging support, what I just spoke about, we have the ability to monitor containers, not just the Ansible container. Any given container can be used, and logger will be alive for as long as the test container is active. And we have a result CR, which is going to take the in the spec of the CR, we are going to have details about the application and chaos type and the test phase and result. So these are some of the recent enhancements. So before I go into the actual next slide, which talks about how litmus is being used in OpenEBS CI, I just probably show you the structure of the repo, which is going to probably give a better picture about what we just spoke. So the structure of the repo has changed, as you might notice. So we have a separate section for apps where we have app support for multiple applications, and each of these is going to contain its own deployer, liveness, chaos, and the load gen litmus jobs. Coming back, there is a separate library that we have created for the chaos utils, and it has been categorized based on provider and tools. So we have OpenEBS specific chaos, which will perform things like killing the target replicas, killing the storage replicas, inserting delays, etc. Then there are some general tool-specific chaos utils, such as killing of a pod via sig kill, and killing of a pod in a graceful manner via chaos using chaos cube. There are utils that are going to perform some general kubectl Kubernetes specific operations, such as draining a node, evicting pods using tames, etc. And probably I'll just open up the design doc to give a glimpse of how the CI spec, the result spec has been created. Result spec sort of looks like this. It's going to contain spec properties, attributes like test metadata, where we're going to specify the app type and chaos type, and the test status, whether it is in progress, whether it is completed, what is the result, whether it is passed or failed. So the litmus books, each of them for the app deploys through to the chaos jobs. All of them are going to update the results here with details. About the load gen, we discussed that we are using the application-specific load gens. So this table is going to illustrate what are the tools that we're using to generate the load. So there is a TPCC runner that we're using for MySQL. The Sysbench Mongo from Percona is being used for Mongo. Cassandra Struts for Cassandra, and the pgbench tool for Postgres. And there are some handwritten load generators that we've created using the respective tool-specific clients. For example, Jenkins Python client has been used to create some jobs, etc. So all the details that we just spoke about have been updated into the design doc. So interested users can go through and provide feedback. So coming to the litmus powered CI pipeline in OpenEBS. Before we go to the pipeline, are there any questions we have till now?
Yeah, hi Karthik, Amit here.
Mhm.
With respect to the folder design, um,
Yeah,
um, I think you have already explained a little bit about the folders, the structure of the folders in your design doc. Will it
yeah,
be possible if those folders can have their own individual README files that explains the intent of that particular package or the folder? Yeah. So, for example,
sure,
yeah. That was my question, query. Yeah.
sure. Yes, we will add the readme summary. Any other questions?
Karthik, Ashutosh here.
Hi, Ashutosh.
Just a naive question. You were showing the CR, which would show the litmus result, right? Uh,
Yes.
so, like, if a test pass, what if the test fails? Like, how can we see the logs from the CR?
Yeah, that's a good question. Um, the CR has been created with minimal attributes as of now. Let me just go over to the CR once again. Yeah, so if you notice that we have a very minimal attributes, mostly talking about whether what is the state of the test, whether it is in running or completed, or whether it passed or failed. So CR is actually being updated in two instances. So at the start of the test, CR is basically updated. So the a JSON merge patch of the CR is performed to mention the respective phase, and it is done at the end again to mention whether it has passed or failed. Now, the location of the logs in the CR is something that we are planning to build. There will be an attribute which will carry the log link. So that is planned, but currently not available. So in the CI that we have in OpenEBS, where litmus is being used, so there is Elasticsearch Fluentd Kibana infrastructure that has been set up, where the logs can be filtered based on the commit, and the logger which we have, which can also be used in the absence of an elaborate framework like PFK. The link of the logs as placed by the logger can also be updated into the CR. So that is something that is there in the works, but that is not available as today.
Thanks, Karthik. You also answered my second question that was coming. Like, we are planning to use this stack of EFK or some logger for this
Right,
use.
right.
Okay, thanks, Karthik.
Okay. I'll just go back to the slides. So this is a schematic diagram which is talking about how litmus is being used, or how it is planned to be used in OpenEBS CI. So this is about the E2E stage of the CI. There will be other stages where the individual OpenEBS components are going to be built. So in the E2E stage, we discussed about the various type of litmus books being present: the infra, provider setup, app deploys, chaos, functional, etc. So the schema is representing the same. So the first part is basically about test bed setup. So there is a cluster setup that will happen using the litmus book for the infra. So you can see below the blocks about what are the various um, uh, platforms that are going to be brought up as part of the same. Then you have the stage for actually provisioning a created cluster. The stage will generally involve attachment of the disks and format and mount of the file systems if necessary. So as you are aware, the OpenEBS has storage engines, namely Jiva and CStore. While one consumes mounted file systems, the other consumes raw disks. So the appropriate conditioning of the cluster will be done in this step. So next step is using the litmus books for provider installs. So OpenEBS operator and OpenEBS storage class litmus books will be executed at this stage. followed by the app deployed stage, where all the supported applications are going to be deployed with the OpenEBS storage classes. There is an app preconditioning step next, where the load gens are going to be run, and so the test will be performed on loaded applications, and this constitutes the actual test bed setup. Each of these litmus books is going to update a result CR to say whether it passed or it failed, and appropriately the CI is going to take action. The GitLab status are going to reflect the results. The next stage is about the execution stage, where we are going to have all the app-specific liveness are going to be launched, followed by the functionality tests of the app. So just like the chaos lib, there is going to be a library containing functional utils, which are going to perform the functionality tests, followed by the chaos tests. So these chaos tests are mostly storage-specific chaos or application-specific chaos tests. So the impact of these chaos tests is going to be localized. For example, it could be delete of the application or the storage PV pod, filling the container through different termination mechanisms, creating delays, disk failures, performing resource constraints for the causing evictions of the pods, etc. This is going to be followed by infrastructure chaos stage, which is going to perform actions like node crash, node maintenance, etc. So this is where it becomes important for us to the importance of the liveness checks running as a separate stage is realized during the infrastructure chaos, where the application liveness is going to be monitored for providing the correct results of the infrastructure chaos test. So there are certain implementation challenges here, wherein the litmus pod, which is running the test itself, should not be impacted by this chaos, so which will be taken care. So this will be followed by stage for cleaning up of the Kubernetes, where all the deprovisioning and scale down activities of the resources created during the tests are going to be performed. This will be followed by the basically tear down of the clusters created as part of the test. So the litmus books will be used in each of these stages. Results will be updated, and the GitLab's job results are going to be derived from the litmus results CR. So this is something that is in progress in the works. A version of this is already running in OpenEBS.ci. So please feel free to visit the same to view this.
Karthik, Amit again.
Yeah.
So the diagram that you are showing, each of those boxes, the rectangles, does it indicate a litmus book, or it's not like that?
Yes, Ramit, you're right. Each of these is indicating one or several litmus books. For example, the app deployer stage is going to have the app deployer stage is probably going to have several GitLab jobs. Each GitLab job is basically executing a individual litmus book.
Okay. Okay.
Yeah. So this was about the CI. The roadmap items, there is an impending release for litmus that is in the works, 0.1, where the current capabilities will be augmented with increased chaos and functional utilities, which will be basically derived from the OpenEBS E2E, which has been running. So they will be converted into litmus books, and at the end of it, we should see the 0.1 release. There are other roadmap items or enhancements or functionalities that are being planned, such as creating an operator model for litmus on the same lines as Maya operator or other popular operators, where it can be installed in a cluster, and you could have the litmus CLI querying the operator litmus API server to either list a test, describe it, run it, view results, or generate a test based on some user input. So there can be templates which the user has filled, and the same can be converted into litmus jobs. So that is a plan that is in progress and is inspired from some of the popular open source tools such as Chaos Toolkit. Litmus is currently doing a very limited job of doing a particular chaos and seeing the results and sort of letting the user know how it is behaving. It is a good fit for CI, but it should be something that is usable even in the staging, pre-production, or production environments where random chaos can be performed using Litmus, and the pre-prod or production testing should also be facilitated using Litmus. So there are chaos utils for that, but there should be a framework which will allow us to use it in this environment. So that is one of the goals that is being planned. Test packaging. Now, if you notice the way the Litmus runners are performing, the Godot runner or the Ansible runner basically take in the entire repo and they are running. There's some optimization planned here where on-demand tests can be run in the Litmus. So this is something that will happen as a consequence of performing or implementing the operator model. So these are some of the items we got. Some of the discussions in the community helped us to come up with the roadmap items. Please feel free to add more feedback in the OpenEBS users channel regarding anything you want to see in Litmus. So that's all I had. I've overshooted by 10 minutes. Sorry about that, Amit. Any questions we have? Around the roadmap or anything is in general in Litmus. Not seeing anything specific in the chat window. Okay. Yeah, thanks, Amit. We will add the README files.
Yeah, okay, fine. All right, so thanks,
Yeah.
Karthik. This is regarding one of the tools from Heptio, that is about Ark. This is one of the tools which is related to storage, and we just thought let us have a look at this particular tool called Ark, which is and how can it be used along with OpenEBS. So basically, Ark is a tool about backup and recovery, and we thought even before writing out a solution with regards to backup or recovery, can we use some of the existing open source solutions out there? Can we go ahead and contribute or collaborate with other open source teams? That was the main intention. And so I have not done a due diligence with respect to Ark. When I say that, it's just been one day that I have looked into the Ark. I basically went through its docs. I browsed some of its source code in the GitHub repository, and this is what I have figured out. Okay. So basically, Ark is a disaster recovery solution for Kubernetes clusters. It's about having a portability between clusters. One can move, one can have a cluster backed up and restored as a new cluster in the event of the cluster going bad. And so this also, in other words, talks about one can replicate a particular cluster, let's say dev, and put it for a test, or vice versa. Maybe try to replicate a prod and put it to QA to check some of the stuff, right? So this is the basic messaging that the Ark says about itself. All right, so we come along with the features. If you see the features, I have tried to list down the primary features supported in Ark, right? The first thing is obviously the backup, then the restore. Schedule is something when we do a kind of a cron job on the backups. There is also a facility to restore from a particular scheduled backup, right? From a particular instance of a schedule, restoration can take place. And they also have block-based as well as object storage-based support for backups. Block-based storage is specifically for the actual data, the persistent volumes, if we talk in Kubernetes terms. And for these, they rely mostly on the cloud providers. They have a couple of support for they have support for a number of cloud providers. For example, GCP, Azure, uh, AWS, and one can make use of those cloud APIs to take snapshots and restores out of those snapshots. The second one about the object storage is typically those files, the objects that can be bundled, and it can be shipped to some object location, for example S3. It's about that. Again, the Kubernetes resources, right? Kubernetes can have a number of resources and all. So those all come under the category of object storage. They can be, clubbed together, and it can be as simple as a zip file, a tarball, and can be uploaded to a S3, storage, right? I talked about cloud providers. Where basically, they support a few of the cloud providers. Almost all the big ones are supported. GCP, Azure, AWS. They have also support for IBM Cloud. This is what I I saw there from the documents, right? Okay, so there is another thing called restic that they have come across. They have come up with. This is what. So as per my understanding, whatever I have gone through the docs, so this is one of the tools. Again, it's an open source tool that they have integrated into the Ark, which can help users to take backups of their data, the persistent volume data, and it is not tied to any particular storage providers, right? And this paves the way for cross-volume, data migration. When I say cross-volume, you can just think of migrating data from one particular storage provider, for example, OpenEBS to some other provider, and vice versa. Um, 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 and this is not just the only intent of restic, in my opinion. So it's also a tool where backups can be taken if the underlying storage doesn't have any mechanism to take backups. For example, if the underlying storage doesn't understand snapshots, restic is one of the tools where users can take backups from that particular storage, right? Finally, there are something called plugins and versus hooks. Plugins are an extension mechanism for the storage providers, for the specific storage providers to provide their custom backup and restore functionality, right? And hooks, on the other hand, are some of the pre and post operations that can be done before taking a snapshot and after restoring a snapshot. And the hooks are you know they are the ones which needs to be set in the pods, in the application specific pods, right? There are some probably they make use of some of the annotations in the pod, which the operator which the Ark operator, one of the Ark operators, makes use of, and calls those custom behaviors, maybe before taking a snapshot or after restoring a snapshot. These were the typical features that I try to list down. There may be some more that I have missed out. One can have a look at the doc site, or probably chat at their Slack channel to get better ideas, better deals. All right, and this is a very very simplistic, simple diagram that tries to explain about what is a backup and how the restoration works out, right? So a backup is done to a particular disk, to a particular persistent disk, and after which the backup is restored from the disk to those clusters or something. And with respect to Ark, we have the Ark mostly talking to the Kubernetes, right? So Ark in itself is designed in a way. Ark in itself is a bunch of custom resources. They are a bunch of operators, Kubernetes operators, which run those reconcile loops for each of the tasks. So backup will be a reconcile kind of a loop, is runs as an operator. Restoration runs as another operator, right? And so the basically they are tied up to the Kubernetes, and well, and let's go to the next slide, which talks about mostly the use cases. By making use of Ark, or Ark can be made use of to solve some of these use cases. For example, I want to restore a particular app, let's say Nginx, on the same cluster, right? To do some kind of testing or something. So that can be done, right? If at all one wants to restore an app to a completely different cluster, it's a kind of a migration of an app. This can also be done. This seems to be done. I don't know the exact details how it's to be done, but after looking over the documentation, I could feel that this is all possible. This would be possible rather, and of course they have the support to restore an entire cluster to a new one, or as a new one. Let's say in case of a possibility of an entire cluster going bad due to some reasons, one can restore back the entire cluster as a new one. And then there are the cases of migration when one can migrate one cluster to a new cluster that can belong to the same cloud, right? The same cloud provider, or to a different cloud provider. And so they have a note where when they say migrating, when a user wants to migrate one cluster to a different cloud provider, they do not support migrating the persistent volumes, right? But then otherwise, the entire HCD stuff, the entire Kubernetes resources can be migrated to the different cloud provider, right? And then there are the cases of migrating cluster from a cloud to on-premise or vice versa. I don't find this particular use case mentioned anywhere in the docs, but then I just thought to give it a shot here, to just mention it. Um, and probably they might have a look at it in the future when they have a proper backup operation, backup restore operation, probably via the Restic toolkit, or maybe via the individual storage providers. This would be possible. Okay, so this was a very brief discussion on the Ark and what it is, what all things it supports as of now. More details can be found out, can be browsed in this location. So they have a location where it talks about the Ark and the various cloud providers, the setup, what is Restic, right? This is all about Restic. Then they talk about plugins versus the hook, and at the end of it, there are some tutorials with respect to disaster recovery and cluster migration. So this is all I have for today's discussion. Any questions so far? What? Okay. Okay. That doesn't seem to be any question. So this was all for today's Contributor Weekly. Feel free to ask your questions on the Slack channel if at all you have anything. So we are good to end this call. Thank you. Okay.